Welcome back. So in the last video, we looked at experiments, we looked at outcomes, trying to use those words exclusively to avoid confusion. And we had the list of all the possible outcomes, and that was our sample space. So we had it, let's see, I had it for one flip, which had two different results, heads or tails. If we flipped it twice, we would have four different results. Granted, two of those are very similar, but not technically identical if you assume that order matters. We also looked at three flips, giving us 8 results. I did not do it because I don't want to have to type it out, but if we did 4 flips, there would be 16 results. If there were 5 flips, we would have 32 different results to have to list out. It gets out of hand pretty quick. Hopefully you're recognizing that we could use a counting formula to track how many possible results we could have. 2 to the first, 2 to the second, 2 to the third, and so on. But now I want to talk about what we use the sample space for. Whether we do it knowingly or unknowingly, we will use the sample space in the simple probability formula. To find the probability of something happening, it's going to always be the number of outcomes we want or we're considering divided by the total number of possible outcomes. And for this equation to work, it has to be the case where all outcomes are equally likely. And that's why we listed 4 results here. Because heads tails is equally likely as heads heads, is equally as likely as tails heads, is equally as likely as tails tails. For that reason, we listed these 4 results out. In order to use this formula, all your outcomes that you're listing or using or counting have to be equally likely. So just some quick notation for you here. When I say P outcome, that is saying the probability of getting my specific outcome that I'm considering for the experiment at hand. If the experiment is known by context or from your writing, you don't have to write it out. But if you are just being totally random, there's not a lot of context to go on, or there's multiple experiments in the same vicinity of your writing, then maybe you'll want some more words. But for instance, if you just wrote PH, the way we've written it here, I would understand that to be the probability of getting heads on a coin flip. If that's not obvious to you or to me or to someone you're writing to, you would write P heads on a coin flip. Or you would write in words the probability of flipping a coin and it landing on heads. Those are all saying the same thing, just one uses more words and another uses more symbols. Note also, and this is going to be important going forward, that probabilities always goes somewhere between 0 and 1. Never goes over 1, never goes under 0. And that should make some level of sense to you because a probability of 0 means there's a 0% chance it will happen. So it'll never happen. On the other hand, you've got P of something coming out to be 1, that's 100%, meaning it absolutely will happen. And you cannot be more certain than will happen. So let me ask you some examples, and I'll stop here and we'll work them in the next video. I've got some examples for you to think about right now. What is the probability of getting a 6 on a 6-sided die? What's the probability of getting heads every time out of 3 flips? What's the probability of drawing a card that is both red and an ace? So remember, a deck of cards has 52 cards in them. There's 4 suits, so there's 13 cards per suit. And those cards are ace through 10, jack, queen, and king. So the ace counts as the 1 in this counting thing. So probability of getting a red and ace, and then finally the probability of getting a red or ace. So you can pause the series here and just kind of think of these and answer them, and we'll check you in the next video. I will see you then.